Hey, it's Dr. Asatar Bear back with you today to talk about applications of elasticity. All right, so we talked about what elasticity is, the responsiveness of a market to changes in another economic variable. So, price of that good, price of some other good, income, or there's many other possibilities there as well. Uh, so now I want to talk about what are some applications of the concept. Okay, so the first question that arises is we're talking about, remember, elasticity of demand, the percentage change in the quantity demanded relative to a percentage change in the price. All right, so the question that comes up, remember, we have the law of demand, which is telling us there's an inverse relationship between inverse relationship between price and quantity demanded, right? So again, as price goes up, quantity demanded goes down. So let's take, for example, let's say that a seller, a producer, has market power. Okay, so say a seller has market power, right? Meaning they can raise the price. There's a lack of competition. They have the ability to raise the price. Okay, so, but the question that arises is, should they? Okay, they can raise the price, but here's the thing: we know what's going to happen, right? The quantity demanded is going to fall. So, the question is raising the price going to be beneficial for the seller? Is it going to actually raise the total revenue? Okay, so let's say that define total revenue as equal to the price times the quantity that they're able to sell, right? So when we say quantity, we mean that's limited by demand, okay? So the total revenue is the product of price and quantity. You can see what's going to happen here, right? The effect on total revenue of a price increase really depends on. Let me draw this a little bit bigger, okay? Let's do it like this. Let's say price, and this is quantity demanded. Okay, so here's the question that we're dealing with. Okay, let's say that we raise the price, but the decrease in the quantity is larger than that increase in the price. All right, and that means that we have one part going up, the other part going down. The entire total revenue in this situation is going to fall, right? Versus if we have, again, price times quantity demanded, let's say we raise the price by a substantial amount, big increase in the price there, but the decrease in the quantity demanded is relatively small, right? So now we have a situation where the increase in the price is outweighing the decrease in the quantity demanded. This is a situation where total revenue is going to rise if we increase the price, okay? So then it's like, well, which one of these is it? Which describes our situation? And the answer to that hinges on elasticity of demand, okay? So when the elasticity of demand is less than 1, when we have inelastic demand, that is a situation where increase in the price will lead to an increase in total revenue. Now, this is of great interest to firms that have market power or monopoly power, all right? So monopolies, as we're going to find out later on when we deal with this section, a monopoly only operates in an inelastic portion of the demand curve. Okay, if demand is elastic, on the other hand, we know that that means the elasticity of demand is greater than 1. An increase in the price will decrease total revenue, right? So a firm that has market power is not going to benefit by raising the price. However, they could benefit from lowering the price. A lowering of the price, because the quantity effect is greater, a lowering of the price is going to raise total revenue. So this helps us to understand what are the situations in which a firm would raise the price versus when they would lower it. Elasticity helps us to understand. Elasticity helps us understand the impact of a cost increase, okay? So a cost increase, how much of that, how will that affect the price, okay? That's our question. So the firm has experienced increase in cost for some reason. How much of that are they going to be able to pass along to the consumer, okay? So pass along to the consumer. All right, so the increase in cost could be from anything, right? But let's take a classic example, okay? A classic example is an increase in cost that occurs due to some tax. All right, so this is called the incidence of a tax, okay? The tax incidence, or it's also called the burden of a tax. All right, so let's consider a situation where we have a new tax, and the question is, how much of that is going to be borne by the producer, and how much of that is going to be borne by the consumer? And so in other words, what is the split between the tax? Okay, so let's say here's our situation, okay? We'll sketch it out with the supply and demand graph. All right, so the price, the quantity, okay, and let's say we have a supply curve and we have a demand curve. And let's say that this is the initial situation, the market at equilibrium. Let's say this market is for cigarettes. All right, we've got an equilibrium here where the quantity supplied and the quantity demanded are equal. And let's say that this occurs at a price of $5. Okay, so now this is the initial supply curve. All right, so we're going to call it S1. Let's say that what happens now is there is a new tax where there hadn't been anything before, and the new tax is paid by the sellers. All right, it's $1 per pack, let's say. Okay, so this would be the price is the number of dollars per pack of cigarettes, and the quantity would be the number of packs down here. All right, so $1 per pack paid by the seller. All right, so typical for how these things work. This tax one's a little bit unusual because it's what's called a lump sum tax, but we're just doing that for simplicity. All right, so $1 per pack. All right, so we'll see how does this going to affect the market, and in particular, who is going to end up paying the tax? Is it all going to be paid by the seller? Is it all going to be paid by the buyer, or is it going to be some combination? All right, and it turns out this hinges on elasticity. Okay, so if the tax is $1, then what's going to happen here is we're going to see the supply curve is going to shift up vertically by an amount that's equal to that $1 tax increase. Okay, so we're going to have, this is an old supply curve and then a new supply curve. Supply curve is going to shift to a different position that's $1 higher. All right, so we've got S1 and S2. Now, I have encouraged you to think about supply curves shifting not vertically but horizontally. All right, that's for conceptual purposes. All right, so this shift, the magnitude of this shift is $1 in the vertical direction. Okay, so now we can see, okay, if this vertical distance right here represents $1, that takes us to a price of $6. Okay, meaning that if the cigarette producer, we assume it's the same as the seller, if the seller is able to pass along that entire price increase or cost increase to the consumer, the new price should be $6. But look at this. Here's the problem with $6. I don't know if you can see this. $6 is not an equilibrium, right? At $6, where it hits the demand curve is here, right? Where it hits the supply curve is here. There's a gap between those things. That's not a market at equilibrium. The market at equilibrium is here, where the two are equal. And we can see that the price which makes that happen is not $6. It's somewhere between 5, the old price, and 6, okay? So these two prices are important, right? So $5, what this means is the seller pays 100% of the tax, right? So meaning if the price was to stay at $5, but now there's this new thing happening, right? The $1 per pack paid by the seller is paying all of that. They only get to keep now $4 rather than 5. At $6, the buyer pays 100% of the tax, right? Both of these things are extremely unusual, all right? The seller hardly ever pays 100%, and the buyer hardly ever pays 100%. Most of the time, what happens is we end up in the middle, all right? So, like in this case, let's say we end up at $5.50, okay? So, at $5.50, what has happened here? Well, the seller is going to pay a portion of it, because here's what happens, okay? The seller, they still pay $1 to the government, right, by the per pack, okay? They still pay $1, but the price has gone up. 50 cents of that dollar is paid by the consumer, right? Because there's a bit of price increase. So now the two, they're at 50-50, right? And that is much more common. Not that it's exactly going to be 50-50, but that the burden of tax ends up being shared between the buyer and seller. To understand this, we have to go into the perfect case scenario, all right? So the economics has this notion of a market that is perfectly inelastic, right? So remember, the definition of inelastic is an elasticity of demand of less than 1. So perfectly inelastic would be, as far below 1 as you could get, right? Where the elasticity is 0. Okay, so this leads to a very mathematically improbable situation where we have something like this. Because remember, the formula is the percentage change in quantity demanded over the percentage change in the price. Okay, so if the elasticity is 0, it means that whatever the change in the price is, the change in the quantity demanded has to be 0, right? So it's totally and completely unresponsive to changes in price. Okay, this top part 0. So that leads to a curve that looks like this, right? The quantity demanded and the price. The perfectly inelastic demand curve is vertical, all right? So meaning if the price goes from $1 to, I don't know, $100, you can see my scale isn't very good here, but the price goes from $1 to $100, what happens? We're moving along the same vertical line. There is no change in the quantity demanded. Let's say the quantity demanded is at 10,000. It's 10,000 at both point A and point B, right? So perfectly inelastic demand curve is totally unresponsive, right? It's totally unresponsive to price changes. And the classic example that was used would be insulin for diabetics, right? So pharmaceutical drugs that you need, and this is a very, intense one example has, this one that's come under fire quite a bit, because insulin in most developed countries that have a national healthcare system maybe costs, like, say, $3, maybe it costs $5. The price is very low, right? In the United States, insulin can cost $700. So it just shows when those who need a life-saving treatment like this, their elasticity of demand is very, very strongly inelastic. Probably there is nothing on earth that is perfectly inelastic, to be honest, because there's always going to be some kind of income effect. The nothing's perfect in this world, right? The income effect tells us that the reason the quantity demanded falls because as the price goes up is because some people are not able to afford it, and that's certainly the situation here. Some people are not able to afford this, and so then we see very sad things in this market. We see rationing. We see people who die because they can't afford it, right? So perfectly inelastic. All right, on the other hand, we have perfectly elastic. All right, and perfectly elastic is different. This is a little bit harder to visualize it. This means it's the most responsive that you can get, right? So think of it this way: the consumer, the buyer, won't accept any price increase. That is, even the smallest price increase sends the quantity to zero. And that is going to look like that's not a quantity demanded price. This is going to look like a totally flat demand curve. It looks like both of these curves violate the law of demand, actually, right? Because this is the weirdness of taking things to the mathematically perfect level, right? So even the slightest price increase sends the quantity to zero. Okay, one way you can remember this is because perfectly elastic, it starts with an E, and an E has all of these, capital E has all these flat lines, right? This is a flat line, versus perfectly inelastic that starts with an I, which has this vertical line in it, all right? So perfectly inelastic, perfectly elastic. How does this relate to our concept of application? Well, so we saw in this graph that if the new equilibrium price is $6, what that means is the buyer is paying 100% of the tax. The only situation that would occur under is if the demand was perfectly inelastic, and that's not really true for any product. I mean, it's probably not even true for insulin. It's certainly not true for cigarettes. Cigarettes are inelastic, but they're not perfectly inelastic. There's still an income effect. There's still a substitution effect. All right. Versus if a market had perfectly elastic demand, then that would mean the seller would end up paying 100% of the tax. They wouldn't be able to pass along any price increase whatsoever. All right. These are so that's normally not the case, right? They're perfectly inelastic and perfectly elastic. We don't even know if these truly exist in the real world. We know that the burden of the tax is going to be shared because companies lobby against any kind of tax increase. Anything that increases their costs, they fight it. The only way that makes sense logically is because they know that they're not going to be able to pass along all the cost increase. If they could, they would never bother to fight anything, right? But firms fight increases in the minimum wage. If they knew they could pass it along completely to consumers, they would never fight it. They would be indifferent. They would never spend money fighting it, certainly. So they know that they're going to take part of the hit, right? Again, the situation here, like it is most of the time, right, is like this one. The seller is going to pay a portion of it. They don't want to pay any of it, but that's probably what's going to happen. Final note: let's just keep in mind, elasticity is not the same thing as the slope of a curve. Okay, so the slope is the rise over the run. All right, so the the change in quantity over the change in the price, right? Versus elasticity is the percentage change in the quantity over the percentage change in the price. All right. Just to show that elasticity and slope are not the same, we could take a straight line demand curve, all right, and we could show that on a straight line demand curve like this, we're going to find there's an inelastic portion, okay, a portion where the elasticity of demand is less than 1. We are going to pass through a point where it's a unit elastic. And then we are going to have a region of this curve that is elastic, okay, where the elasticity of demand is greater than 1. And that's along a straight line, okay? Obviously, along a straight line, the slope is constant, all right? So the slope is not going to vary, but the elasticity is going to vary. The number is going to change going from this position to this position along a curve, all right? And that's because the relative change, okay, the relative change in price over here, like let's say we go from 1 to 2, right? This is that increment, right, this size increment going from 1 to 2, is a pretty big relative change, 100%, right? But up here, okay, it's 3, 4, 5, 6, 7, 8, 9. On this portion, right, as we go from 8 to 9, that's still the same size change, okay? So for slope, it's going to be constant. But that is a different relative change, right? Going from 8 to 9 is very different from going from 1 to 2 in percentage terms. Okay, so because elasticity has percentages in here, it is going to vary even along a straight line.